Today's lesson might be, or it's not new. You guys have done this definitely, and you guys talked about function notation definitely in junior high, and definitely in Math 1. Math 2, we don't really talk about it. But in Math 1 and 8th grade, 7th grade, I can't remember when, you guys talk about function notation. So if the stuff that you see today, you're like, oh yeah, I know that. It's okay. It's all right. The reason I do it is just to make sure that everyone remembers, because we're going to be talking about function notation this year. Okay? So it's the idea. So today we're going to be asking two questions. If x is something, then what is y? Or vice versa. If y is something, then what is x? So they're always going to give you half. They're going to give you x, or they're going to give you y. Your job is to figure out what the other one is. Okay, there's three ways to do it. One way is using equations. One way is using graphs. The other way is using tables. Okay, so we're going to go over the three ways, the three methods on how to do it. So the first question we need to ask before we get here is, what do we know? What do we know and what are we trying to find out? Okay? Okay. So let's look at example number 1. Equations. These are equations. So they'll always give you the function. This function's name is f of x. It's its name. Okay? The equation part is negative x squared minus 7x. Okay? And then they give us something else. They say find f of negative 1. F of negative 1. So our first job is to figure out, is negative 1 the input or the output? Input is x's. Output is y's. So what do they give us? Is negative 1 an x or is it a y? It's actually x, yeah. It's actually going to be the red, x. Yeah, what gave it away? The x which part? The parentheses, right? The parentheses, right? Yeah, f of, that's always x, right? We're trying to figure out what y is on this one. So this guy here is x. So our question is, then what is y? What is y? Okay, so when you're doing this on equations, you're going to use the function, the green part. So since x is negative 1, everywhere I see an x, I'm going to put a negative 1. So I'm going to rewrite. First step is rewrite. So let's rewrite. F, except no more x. I'm not going to put an x inside the inside anymore. Oops. I'm going to take those away. What I'm putting in its place is parentheses. All right? Now we know what x is. We just said x is negative 1. So I'm going to put a negative 1 inside all of those parentheses. And then there's an equal sign, so anytime it's an equal sign, I just draw a line down the middle. Okay? That's why that blue line's there. Okay, so the left side of the blue line, f of negative 1, that's the name. That's its name. Like you guys all have names, right? This guy's name is f of negative 1. We all have names. F of negative 1. Okay? The right side is what we're focused on. I need to simplify that. So to simplify, we're going to use PEMDAS, or some teachers cheats GEMS. It's the same idea, right? So when we do this, we always do parentheses first. Do we have any parentheses here? Yes. I do. So inside those parentheses, can I do anything? Do anything means can I add, subtract, multiply, divide? Inside the parentheses, is there any addition, subtraction, multiplication, division? No, just the negative 1, right? So I really can't do anything. I do have parentheses, but I can't do anything inside. So let's go to the next step, exponents. Do I have exponents? I do. I have a squared, right? A 2, a power of 2. Okay, so remind me, what is squared mean? What does the little 2 on top mean? Not times 2, you're close. It's times itself, right? Times itself. Yeah, there you go. Times itself. So what is times itself? -1, right? Good. So this guy is going to be times itself. So what is -1 times itself? +1, right? So we're going to change this guy to +1. Everything else that I haven't used is going to come down. So have I used this negative in front? Not yet, so it's got to come down. All this stuff too has not been used, so I got to bring it all down. Okay? No more exponents. Do we have any multiplication or division? Yes, right? We do, right? -7 times -1. We have a -7 times a -1. What is -7 times -1? +7. So it's a +7. Bring down everything we haven't used. Now we just have addition. -1 plus 7? +6. So I need to bring down the name. The name is f of -1 is 6. So when we plug in -1, what do we get as an answer? What is the output? 6. There you go. Okay. All right. All right, let's go to number 2. Okay, so here's the function here. It says solve for x when f of x is -4. So -4 now. Is -4x or is -4y? There's a couple different ways to tell. So there are x's, right? So there's a couple ways to tell. It's actually y. -4 is actually y. How do we know? This is how we know. 2 ways. First of all, it says solve for x. If I have to solve for it, do I know what it is? No. So that means if I don't know x, I have to know y. That's one way to tell. The other way to tell, the easier way to tell, is look at this guy over here. What's -4? Where is -4 in what spot? It's in the y, right? It's in the y. So that's how you know it's y. So -4 is not x, it's actually y. So our question is, what is x then? So last one, we knew what x was, so we plugged it in and solved. We can't do it that way because we're asking a different question, right? I can't plug in -4 for x because it's not. So what do I do? Here's what you do. So we know f of x equals -4, right? What does equals mean? Like in math or real life, when someone says 2 things are equal or 3 things are equal, what does that mean? Same, right? They're the same. For example, if I have a $20 bill in my hand, and in the other hand I have 2 $10 bills, are those the same? Do they look the same? No, they have different people on them, right? Same color, but they have different people on them. And one of them's 2 and one of them's 1, right? But can I swap them and them be the same? A $20 bill and 2 10s? Yeah. That's what we're going to do here. We're going to swap. I know that f of x is the same thing as -4. Well, is there an f of x over here?
Yeah, you're going to take it out.
There you go, right? So first step is let's rewrite it. Let's rewrite it again. F of x equals -3x plus 5, right? I'm going to rewrite it first. Then I'm going to do a swap, right? We know it equals -4. They're the same thing, right? So instead of writing f of x, I'm going to change this to -4. Why did I change it to -4? Because they're the same thing. It told me so. Right? All right, so now I'm going to draw my blue line. So the question asks, solve for y. Or sorry, solve for x. It said solve for x, right? Solve for x. So that means I have to solve for this guy right there. How do you solve for it? Yep.
+4 on both sides.
Close. You're close.
Or +3x.
No, not yet. We're going to do all those things. You're not wrong. We're going to do all those things. We're going to do the opposite. So to solve for x, you're actually going to use PEMDAS. You're going to start at the bottom. You're going to start at the bottom and work your way up. So we're not going to start with P anymore. We're going to start with A and S, addition, subtraction. So x is on the right side of the blue line, right? So I want to get everything away from that. The only thing I want to stay here is that x. That x is the only thing I want to stay. So the -3 and the +5, I want to move to the other side. To do that, I have to do the opposite. So which one do we do first? Well, we do the addition and subtraction. Is there any addition and subtraction over here? Yeah. +5, right? +5. Do the opposite. What's the opposite of +5? -5, -5. Yep, I got to do that to both sides since they're both equal. Equal signs in the middle, that means you do the same thing to both. So I have a +5, take away 5, that becomes 0. So I just put a line through. On the other side, I got a -4 minus 5. -4 subtract 5 is -9. Bring down everything I haven't used. Now the right side is starting to become smaller because that's what I want to do. I want to get rid of everything except the x. So now I got to take care of the -3. So to figure out, so I have 4 options. I can divide by -3, I can add -3, I can subtract -3, or I can multiply by -3. Which of those is the correct answer? Because, yeah, why division? You're right, but what's going on over on this side? Is this, what is -3 and x doing? Adding, subtracting, multiplying, dividing? Multiplying, right? Anytime a number and a letter are stuck together, it's always multiplication, right? Now, what's the opposite? Division. So what am I dividing by? I'm dividing by everything that's not x. Divided by everything that's not x. So that's, this case, it's going to be -3, both sides. Any number divided by itself. Any number divided by itself is always going to be what? +1. So we're going to have 1x, +1x over here. And then 3 goes into 9 3 times. What's a negative divided by a negative? Positive. So when y is -4, x is +3. Solve for x, that's what x was, +3. So when y is -4, x is +3. Okay? So that's how to find x and y if they give you an equation or a function. So let's go, how about the next one? The next one is on the inside. Now we got graphs. So people always look at graphing, they're like, oh, graphing, that's so. Graphing's actually sometimes, most of the time, it's actually easier. Why is it easier? Well, graphs are just pictures of stories, right? We talked about that last week. Pictures of stories. It's telling the same story, but just a picture. So it's like reading a book versus watching a movie, right? There's books that they make into movies all the time. Or sorry, books they make into movies all the time, right? What would you rather do, read a book or watch the movie of it? I'd watch the movie. Some people like to read. That's okay. Nothing wrong with that. But me, I like to watch the movie version. That's what you're looking at right now. Okay? I'll show you. First thing we got to do. What do we know? Do we know X or do we know Y? Because it's in the guy, right? -6 is up here. So that's how you know that we have X. I know what X is. I'm trying to find Y. Okay. So that's what I'm trying to find. Okay. So I know X is -6, but I have nowhere to plug it in. I just have a graph that I'm looking at. So where do I plug it in? Well, this is what you're going to do. With your pencil, put your pencil where X is -6, because that's what they said. X is -6, right? Where's your pencil? Put your pencil where X is -6. Where would I put that on here? You go left right there, right? -6. Right here, right? Don't make a dot. Don't need to make a dot, but that's where you'd be, right? That's where you'd be. Okay, so where is the graph? When I say the graph, I mean the upside down U, the parabola. It's called the parabola upside down U. So if I'm at -6, because that's where it told me to go, X is -6. If I'm here, where do I have to go to find the graph? Up or down? So if I go up, am I going to ever hit the graph? No, right? I'm not going to hit it. So I got to go down. So I'm going to keep going down until I touch the graph. So how far am I going to go down until I touch the graph? It's a -8, right? I think -8 is the one, this guy right there. -8. I don't touch the graph. The graph is the parabola, the upside down U. Right? So what dot did I just make? -6, comma -8. That's the dot I just made, right? Well, which of those did we already know? -6 or -8? -6, right? So what do you think our answer is going to be? -8. Done. They'll always give you half of it. They'll always give you half. You just got to figure out the other half. Okay? All right, let's go to example 4. Example 4. Another picture, another graph. This time the graph isn't as big. All right, it's down here. It's actually the same size. They're actually the same size, but actually these two. So if I ask, so this is a good question. These two parabolas, you see the upside down U's? Which one would you say is bigger? It's kind of a trick question.
The smaller one is like more because the other one is in the negative, so it doesn't really count.
Yeah, we stop drawing it after this, right? After it passes -10, we stop drawing it. Doesn't mean it's not big. It's just we just stop drawing it, right? These two guys are the same size. If my graph continued, it would be bigger. Right? So just because this guy here stops and looks smaller, those arrows tell me that it goes on forever. Okay? So just because that happens, yeah, don't assume that it's tiny. No, it's just tiny on our graph. Okay, but that's it right here. Okay, so the graph of y equals f of x is shown below. Find the values of x where f of x equals -6. So what part did they tell me? They gave me the y, and the y is -6, right? They said y is -6. The question is, what is x? So start with this. With your pencil, where is y equal to -6? Don't need to make a dot, just put your pencil there. Where is y equal to -6? Am I in the right spot? No, this is x, right? I should be down here. Your pencil should be down here. Okay, so now to get to the graph, Do I go left or go right? Right. I go right 1, make a dot. And then is there another one too?
Yeah, 3.
3, yeah. So I'm going to make 2 dots. I'm going to make 2 dots. 1 here and 1 here. So now I'm going to give the addresses of those 2 dots. So to find this first dot, I'm going to go right 1, down 6. So 1, negative 6. To get to the other dot, the address is right 3, down 6. Those are just addresses, right? We all have addresses where we live, right? That's the way people can find you, right? That's how you can find those dots, right? Sometimes telling your friend, yeah, I just live 3 streets over and this street, sometimes that's not the best. But if I give you directions, you can easily get there.
I'm not too sure, but is that called a vertex?
That's a good job. That's what we're going to talk about next chapter. The top is called the vertex. Yeah, the top is called the vertex. The top or the bottom of the parabola are called vertexes. That's good. Next chapter, we're going to be talking about that. Yeah, for sure. Okay. All right, so what is my answer? What is x equal to?
1 or 3.
Both, right? So I put 1 box for 1, 1 box for 3. Because there's 2. It touches the graph in 2 spots, not just 1. Okay. That's how to do a graph. That's how to do a graph. The last one, table. How the heck do I do a table now? Same question, but I have tables instead. Okay. Well, tables are really graphs. They're just too lazy to draw them. It should have been a graph like we had on 3 and 4, but they're just too lazy to actually draw the graph. So they just gave us the table. Okay? That's all it is. Besides that, what else is different? There's something else that's different.
G and H.
The letters, right? G and H. G and H. Is that going to change anything we do, G and H? No, not at all. They just have different names. Just like you guys have different names, right? You're all students. F of x is usually the formal name. F of x is usually like student, like you guys are student, I'm teacher, right? But you guys have individual names. That's why these guys have different ones, right? Okay. It also labels what you're going to use. G goes with the table. H goes with the table, right? So it helps you when you're looking at, like, example number 7, we have a table, we have a graph, and we have an equation. Which one do I use? Use the letters. Use the letters. That one, that's what will tell you where. Okay, so -1. Is that x or y? Because it's inside the parentheses. It's going to be x. Okay? So we know x is -1. What is y? So how do we use the table? We'll go to the table and find where x is -1. What goes with it?
3.
That's the answer. 3. Done. Okay? It's not hard, but it's like a different language. Function notation is like a different language. If you understand function notation, it's very easy to use. But if you didn't know function notation, it's hard. It's like a different language, right? Speaking English to you guys is very easy because you guys know the language. But if you went to a German language class or a Russian language class, if you didn't know how to speak the language, you'd be lost, right? That's what function notation is. It's just a language, mathematical language. And if you know how to speak it, the better you are, the easier it is. Okay? So 7, what is 7? X or Y?
X.
What is Y?
-9.
There you go, -9. Because 7 goes with -9. Okay? All right, so what I want you to do next, the last thing we're going to do is I have a check for understanding part. One of the things you guys told me last week was, Mr. Flores, we like when you check for understanding, when we can ask questions and all that stuff. So that's what I'm doing on example number 7. Number 7, I want you to figure out what each of these are. A, B, C, and D. It's got 4 parts to it. How do you know which one to use? Like A, G of 4. How do I know if I'm going to use the graph, the equation, or the table? Which am I going to use for that one? Am I going to do the graph, the function, or the graph, the equation, or the table? For this guy here. What letter does it have?
Oh no,
There you go, the equation, right? You're going to use the equation. You're going to do like we did on number 1 and number 2. All right? Letter B is H. The graph. So you're going to do like we did on 3 and 4. All right? F. Table, 5 and 6, like we did on 5 and 6. And then 7 is also the table. Okay? So I want you to do is I'm going to give you 5, 10 minutes or so. We got plenty of time. We're not rushing for time. But I want you to try these. If you're stuck, let me know. I'll be walking around. Alrighty, guys. Okay, so A, they give us X. B, they give us X. C, they give us X. D, they gave us Y. Okay, so let's go through this one at a time. So A, letter A, G of 4. So I know 4 is X. Where is G? G is over here, right? So that means everywhere I see an X, well, first thing, rewrite it, right? Rewrite it. With parentheses. Now plug in your X. Okay. So now what we're going to do is simplify using PEMDAS. So we're going to do parentheses, exponents, multiplication, addition, and addition, subtraction. Okay. I'm going to show you a quicker method though. I'm going to show you a quicker method that you can use. So there's 2 apps. Well, Delta Math we'll use tomorrow, but then there's also on my, they both work the same, but on my iPad, it's easier to get to this website. It's called Desmos. Some of you have used Desmos. It's their calculator, their scientific calculator. It's an app, and it's a website. Okay. It works the same as Delta Math's calculator when you see it tomorrow when we're doing the practice assignment, but you can do this, watch. What I'm going to do right now is I'm going to plug in, remember, we just want this side here. -2 parentheses 4 to the 2nd power minus 4 minus 4. So -2 parentheses squared minus parentheses minus 4. And then I wanted to plug in, what was it, 4? Yep. 4 and 4. You get -40. Okay? The reason I'm showing you this is because you guys have been doing this stuff. You guys have been doing this stuff for, years. I think you started doing PEMDAS in elementary school, and you did it in junior high, and you did it in Math 1 and Math 2. So by now, you're past that, right? You're past that. So that's why you can use your calculator. But, I'll caution you. So let's say a student has this question, and on a test they give me this answer. That's it. Out of 4 points, because on the test, when we take tests and quizzes, each question's worth 4 points. How many points do you think I would give them for this answer here? It's correct. It's correct. We just checked it. It's correct. But if that's all they put, how many points do you think I'd give a student? 1 point. You get 1 point for the correct answer. You get 3 points for telling me how you got there. Did this student tell me how they got negative 40? No clue. No clue, right? This student over here, they used their calculator, but do I know where negative 40 came from? They plugged in 4. They rewrote it and plugged in 4, and then they used their calculator. This person here, I'd give full credit. That's the right answer, and I know exactly where negative 40 came from, right? I don't want to be guessing where it came from. Oh, negative 40 came from over here. I don't know that, right? Here, I know that. Over here, I don't know that, right? So when you're doing independent work, that's the work I want to see. It's not a lot, but that's the work I want to see so that I know you know where it came from, right? Okay? So negative 40 is the first one. So we got negative 40 over here. Second one, h of 4. h of 4. Well, h is the graph, and x is 4. So with my pencil, let me go figure out where that is. Right there. Where's the graph? Up or down? Down, right? Yep, negative 5. So this one's at negative 4, or sorry, not negative 4, positive 4, negative 5. I already knew the 4, so now I know the negative 5.
So the first one is put y equals negative 40?
You can. Yeah, it's not wrong. You can. Like if you put y equals here, I didn't, but yeah, if you put y equals, and the second one you put y equals negative 5, I'd give you full credit. F of 4, F of 4. 7, right? D, they flip it. D, they say when y is 8. So that's over here, right? That's the table. So which one of these guys is 8? What's the x that goes with it? 9. Done. Okay. So there's tape in front. There are tape in front of you. Tape this into page 6.